We'll just, I kind of told you guys yesterday how today would be set up. We'll do some examples with semicircles and triangles, and then it shouldn't take horribly long because I think you guys understand the setup now, but we'll kind of go over it again. So we should be done relatively quickly today, so you should have some time to work on your homework. I saw a few people already started it. That was awesome. And it's not like it's nice out, so you're not going to want to go sit outside. Gotta have something to do. Okay, so let's do this one first. Did the attendance not work? I doubt I marked you absent. So, if I'm honest, 90% of the time I forget to go check to see who's attended virtually. So I usually just click present because you can watch the video later, and then I kind of count that as attendance. So it probably wasn't me. Oh, I went to go look. Never mind. It's on Friday's attendance, so I'm not going to be able to check. Okay, so do you guys have this written down yet? Basically, try to get the picture. The equations are written next to it. If they're not clear enough, I can write them bigger or whatever. But we're going to be trying to find the volume that's created by having cross sections perpendicular to the y-axis, and the cross sections are in the shape of a semicircle. So this one actually is pretty decently easy to picture. If you can kind of think of this shape being rotated, and it would create essentially like a really tall bowl, right? This would be half of the bowl because it's a semicircle, but it would be solid. So for us to find volume, we are going to integrate the area of the semicircle. So our goal is to kind of figure out the equation to find the area of the semicircle. And then obviously we have to have numbers right here. And this one says cross sections perpendicular to the y-axis. Well, that definitely tells me that it is horizontal. So then this would be dy. So everything has to be in terms of y. So let me get a line made up here. So this line, oh, that looks terrible, but we'll go with it. Can I fix it? Nope. Okay. Let's go. What's this? No, I don't want to do that. Or turn that off. Crap. There we go. So, you know what? I'm just going to erase that. Okay. So right here, when it tells us it's perpendicular to the y-axis, my bases, this would be perpendicular to the y-axis. And this question is slightly different than ones we had yesterday because this is using the whole parabola. So my cross section is going to sit flat like this. Now, I know it's going to be in terms of y because it's horizontal. And for me to find the length of this line, I'm going to have to take this x value minus this x value. So when a line is vertical, you have to take the y value on top and subtract the y value on the bottom. So that's kind of how I knew it was in terms of y. So before I start worrying about, well, no, actually, I should figure this out right away. Let me figure out what I even need to find out. Because now that I drew that line, I'm realizing I didn't need to draw that whole line. That's just me doing it out of habit. So the area of a semicircle is 1/2 r pi r squared. You know what? It's not like it's any earlier than a normal day, but man, am I tired today. So the half is because it's a semicircle. The pi r squared is the area of a circle. So really the only thing we need to figure out is r, the radius. And when I said a second ago here, I drew this line kind of out of habit. I did, because I don't need that whole line. I actually only need half of the line because this would be a radius. So if you picture your semicircle coming, oh my god, this is so hard to draw on this tablet, I forgot about it. If you picture your semicircle coming out, like coming straight out of your monitor, what I have highlighted darkly would be the radius. And so I want to find the length of this line as my radius. And honestly, I could choose to do this side as my radius. It won't matter, you get the same answer. We just need to find the length of the radius. Go ahead. At the very top of our shape, the radius would be 2. No. No, actually, I don't even know how long this is because that's at a height of 4. So this equation right here determines how wide it is. The x squared equals 8y. But the problem is our radius is different at every spot. It has a different length every single time. So each one of these radii that I'm drawing is going to make a semicircle coming out of the shape to make a volume. And each one of them has a different length. So the integrating symbol is how we decide to add up an infinite number of things. The formula is for finding the area of each semicircle. And because each semicircle has a different radius, we need to figure out what to put in place of it. So this equation right here is x squared equals 8y. And it's almost in terms of x. We need to find this equation so that it says x equals instead of x squared. So the right half would be square root of 8y. The left half would be negative square root of 8y. And I purposely need my equations written in terms of y because I'm doing this horizontally. So the right-hand side of this line that I have drawn, my radius, is square root of 8y. The left-hand side of this line is x equals 0. So the left-hand side never moves, but the right-hand side does. So the radius, which I'll simplify, would be square root of 8y minus 0 squared. And then I can put the numbers on now because I know that I am integrating from y equals 0 to y equals 4. I'm doing it horizontally. And then this is one that we can do exact, like we don't need a calculator. So 1/2 pi I can pull out front because they're just multipliers. Square root of 8y squared would be 8y. And then 8y I can integrate into add 1 to the power, divide by new power. And instead of writing plus c, I write 0 to 4. So this is 4, and the half in the front would become 2. So if I put 4 in, I would get 16 times 2 would be 32 pi minus, plugging in 0 would be 2 times pi times 0. So the volume, my God, the volume would be 32 pi. And we don't have any units, so if it bothers you, you could write units cubed. But, you know, regardless, go ahead and start asking away if maybe there's things you forgot from yesterday. This one, I like to have this as a first example because it had things we didn't do very much yesterday. Even though it's the same idea, it kind of feels different. Yep. Nope. So, no, we didn't. Nope. Wait, are you talking about this one right here, Daniel, that I circled? I circled it in green. Yeah, that's the only reason. If my radius was up, if the radius is on the left-hand side with the pink, like, let's say the radius was right here, the radius would be 0 minus negative square root of 8y, which would turn out to be the same answer. Yeah. Yep. Okay, somebody else was saying. Oh, Bella, go ahead. Oh, and Natalie, go ahead. Yeah. Yes, that's how long this... Let me erase the pink here. My radius of my semicircle is right here that I'm highlighting in pink. And normally when you're trying to find the area of a semicircle, your radius is a number, like your radius is 5 inches. But our radius changes size constantly, and so we can't have a set number. So what we do is we take the equations and subtract the two equations to find the length of my radius. So when it's vertical, you do top minus bottom to find the length. When it's horizontal, you do right minus left. Correct. Yep. By broke them up, do you mean the left half and right half type thing? Not really. It's debatable. So if it wasn't on the origin, this equation would be different. So the only reason I broke them up is because it wasn't a function. Like I just went through the work to make the equation say x equals, and by doing that I got a plus or minus. So if the equation was different, I mean, I guess it depends on how it's written. But you can still solve it for x equals with a plus or minus. The split up wouldn't affect, or I mean, excuse me, the origin doesn't affect the fact that it's split up. The parabola could be anywhere, and I could have split it up. Because it's at the origin, there's no other numbers. Like if there was a, it's not writing anything. If there was a +2 here, this would move it 2 to the right. If there was a +2 on the left-hand side, it would move it 2 to the left. I mean, like, so because there's no extra numbers being added or subtracted, it's at the origin. But otherwise, that's the only reason it would be different. Okay, maybe I'll move on to the second one now. So on this one, the main difference is that the cross section is an equilateral triangle. I'm trying to pick this one because I think this would be the hardest for you. The one on the AP test and the one on my tests will be easier. So I am only going to test you on the same things that AP would. So I'll give you guys a minute to write down this picture, try to sketch it type thing. Do you mean yesterday or the last test? Mm-hmm. Because we're finding the volume of a three-dimensional picture. I mean, like, I have the bottom of the three-dimensional picture drawn for you, the base. I could pretend to try to draw this, but it would just take me a long time. Basically, so what does this one say? Perpendicular to x-axis. So on this particular picture, there's an equilateral triangle coming out of the screen at every location. And this would be some sort of a weird shape that would kind of look like a triangle whose top would kind of follow halfway through the curve, and then it would constantly have flat sides going down. I guess it would look like a weird tent, now that I draw that. It would look like a curved tent when it's done, because there would be equilateral triangles sticking out everywhere. If you can kind of follow along with that sort of picture. But otherwise, essentially the problems aren't much different than what we did the last test. The main difference is you trying to figure out how to calculate them. Okay, so let me redraw that. So I'm drawing a cross section to help us figure out the answer to this problem. So we will just take one equilateral triangle. And I know they put these equilateral triangles because they feel like it makes it easier, but I hate it because it's not easier. Okay, well, for us to find the answer, we are going to have to integrate from beginning to end, and I'll just start putting this stuff in right away, from x equals 0 to x equals 1. So my integral is going to be from 0 to 1. And I'm going to integrate the area of the equilateral triangle, and it's going to be dx because I'm doing this vertically. So in the equation, all things will be x's. Well, then let me figure out the area of my triangle. I don't know the formula off the top of my head, so I'm just going to calculate it. Like, that's fine. But I know it's going to be based off of this line that I drew. So my formula has to be from the base. So if I draw an equilateral triangle, it's a normal triangle where it's 1/2 base times height. But my height, I need to put in terms of a base. So because this is equilateral, we've got 60, 60, 60, and the one on top is split in half because it's equilateral. So a 30, 60, 90 goes in a ratio of 1 to 2 to square root of 3. So the height is square root of 3 times bigger than this number. This number that I just underlined in red would be 1/2 b. So my equilateral triangle will be square root of 3 times 1/2 b. Now if I put all of this together, I get square root of 3 over 4 b squared. Now you could have also just Googled this, and you probably would have found a formula for area of an equilateral triangle. Like I said yesterday, I don't remember it, so I just figured it out. So integral 0 to 1, and the area of the equilateral triangle is square root of 3, which I'll put up front, b squared dx. No, we're fine. I was about to get mad at myself because I wrote a b instead of an x. Now I need to actually calculate how long the base is, because the base changes size constantly. My base is going to be the top number, which is e to the negative x, minus the bottom number, which is 0. So I'm going to have e to the negative x minus 0 in place of b. And then obviously the minus 0 doesn't do anything. So I've got square root of 3 over 4 integral 0 to 1. If I square it, I'm taking a power to a power. So this would become e to the negative 2x dx. I'll pause here. I don't know if you guys need to catch up or if you have questions, because I have a feeling you guys forgot how to do a lot of integration, so I'll wait for a second for you to catch up, because you might have questions on the integration. Wrong direction. the height of this point is 0, not the x value. Where did the E come from? Oh, it might be super light colored on your screen. The E came from the equation that was given to us from the start. The blue line is y equals e to the negative x. Where the square root of 3 came from. Geometry. If you have a 30, 60, 90 triangle, every 30, 60, 90 triangle is in the same ratio of 1 to 2 to square root of 3. Now, our triangle, this length was 1/2 of the base. So the height of our triangle would be square root of 3 times 1/2 the base. Oh, why is this rate so slow? There we go. Oh, same. Is that kind of clear up where the square root of 3 came from? I mean, like, no. So, Chidera, you're thinking of an isosceles triangle. An isosceles triangle, oh god, that's a bad picture. Isosceles triangles is when these two sides are the only thing that's the same. So it would be 1 to 1 to square root of 2. And then that would be a 45, 45, 90. An equilateral triangle is when all three angles are 60. I was only looking at half of the equilateral triangle because I needed to figure out the height. Why did I multiplied it by 1/2b again because a full triangle has 1/2 base times height formula. The height of my triangle was square root of 3/2b. So 1/2 b was there from the start, and then instead of height, I wrote square root of 3/2b. Sure. Do you guys want me to continue with the integration now? I don't know if you're caught up or have questions kind of answered. Oh, we actually have to hurry. It's already 9:30. And here I thought this was going to go fast. I should have known 3 problems would be not quick. So e to the negative 2x. There's so many colors. I guess pink. This thing's acting weird. So e to the u has to have du correct to be able to integrate. The formula is the integral of e to the u du is e to the u plus c. So currently, my du isn't correct because the derivative of negative 2x is negative 2 times dx. So I'm going to multiply by negative 2 to make du correct, and I'm going to multiply by negative 1/2 in the front to offset that negative 2 I just put in. So then I get negative square root of 3/8, and now I can integrate e to the u du, and it turns into e to the u. Instead of plus c, I'm going 0 to 1. So I'm going to plug 1 in. Then I'm going to plug 0 in. And this would be the exact answer. And obviously, if it's a calculator question, you just type the whole thing in and get the decimal. But my guess is this would be an example of a find by hand. Again, you're not going to have an equilateral triangle on my test or the AP test because they're just more work. On my test or the AP test, you will only have isosceles right triangles, which I think is the next question I put. So formula for an isosceles triangle is a lot easier. Okay, because of time, let me just go right to the last one. I wanted you guys to be able to just try it on your own. Cross-section perpendicular to the y-axis are isosceles right triangles whose base is the leg of the triangle. What that means is the triangles will be sticking up like that. So see if you can find this answer. And you know what? Here, I'll write this one down because this equation, if you can't read it, is x plus y equals 1. And then obviously the other two equations are x equals 0 and y equals 0. Okay, since we are done in 5 minutes, I didn't want to wait too long to put up the answers up here. So the base is a horizontal line. So to find the length of that base, I have to take the right value minus the left value. So it would be 1 minus y minus 0. And the area of a isosceles right triangle would be 1/2 base times height. Base and height are the same, so it's 1/2 base squared. So I had 1/2 1 minus y squared. And I'm basically assuming that these were all to be done by hand, but it's whatever. So to do this one by hand, I pictured this as u squared, and the derivative of 1 minus y would be negative 1y. Negative 1 dy. So I put in a negative symbol and counteracted it by a negative symbol out front. And then that gave me negative 1/2 times u cubed divided by 3. And then I just plugged in the numbers. And I don't know if I plugged them in right or not. I don't even have a calculator with me. So we'll not let that fact be known that your math teacher doesn't have a calculator on him. Did anybody else get the same answer? Or does anybody else have same, questions on something I put up there? Okay, good. Yep. You would if I actually wrote u. So if I did so I did it mentally. Well, because these are y values. So these numbers are the same variables as what you have written in the problem. So if you physically write u substitution in there, then you have to change the numbers to be u's instead of y's. You get the same answer, so it doesn't really affect anything. I just don't like doing it, so I usually don't. I prefer to do u substitution in my head just because it works better for me, but I know it doesn't for everybody. So if you are a person that likes to write down u substitution, you absolutely could have. And what you would have done is this, and used this information. My u's and y's look so much alike. So if you wrote down u substitution, you would have written down 1/2 integral from 1 to 0 of u squared negative times du. The negative sign you would have brought out front. And you could have calculated it this way as well. And that would have still got you the same answer. So it's just kind of how you like to do it. Okay. Yep, I got you done a whopping 1 minute early when I said we were going to be done quick today. Sorry. It was my intention to be done early. I guess it's hard to do that in Calc. So I do have the assignments up in Schoology for you guys. Try to work on them by Monday. If you felt like squares and rectangles were a lot easier, obviously practice a lot more of those first. And then move to triangles and semicircles. Because it's the same ideas, just different shapes. Okay, you guys have a good weekend. I'll see you Monday.